Hello, everyone. So 14, part 2, module 14, part 2, confidence intervals, part 2. The same thing we just did, except since we're talking about the mean, we're going to try to find t of alpha over 2 instead of our z of alpha over 2 that we were using. And we're going to do this. There it is right here. There's our margin of error equation. I'm not going over this as in depth because it is almost exactly the same as the stuff that we've been doing. So we're going to find t of a over 2 first by using this table, and secondly by using our calculator. As you can see, our lower bound and upper bound are still our x bar minus e, or anyway, our mean minus our margin of error and our mean plus our margin of error. Let's go down and just go through one. And I think that you will get a good idea of what we're talking about. So this first one is just, this first little piece of information on this page is just showing us how, it's a terrible curly bracket, is just showing us how to use the calculator. So if we want to, so here's something you've got to be careful of actually. Looking at this degree of freedom is going to be in the table. Instead of just our sample size, like for this first example, our sample size is 20, our degree of freedom is going to be 19. It's going to be n minus, minus 1 is 19, and that's going to be our df. And you'll need that when you look at the table. So we're looking for 95% confidence. Our degree of freedom is 19. So let's go to our table. So if you look, let me move, see if I can I move this? Can I move this? It's not good. It's not even any better. Okay, let's try that. Well, it'll just be there. Our degree of freedom right here is in this column. So this is where we were looking for 19. So it's here in this blue piece. And we're looking for 95% confidence at the very bottom. We're looking for 95% confidence. And you can see up here at the top, it's saying if it's both tails, what's left over is 5%. And if you're only talking about one tail, it is 0.25. But regardless, the number we're looking for to put in our equation is, in this case, 2.093. So on the left-hand side is your degree of freedom. On the very bottom is your confidence level. And at the top, it's talking about the area that's left over for those tails. The same thing we were talking about in 14.1. Okay. So what is this talking about here? Let's see. I'm going to try to move this. I didn't know this is going to be so annoying to the background, to the bottom. Okay. So find the value of, oh man, and I just forgot what it was, 2.093. So our T of alpha, terrible alpha, T of alpha over 2 is equal to, and of course I forgot it, 2.093. Yeah. Okay, and that was just helping you figure out how to find that, okay? And now it wants us to do a 99% for a sample size that is 51. So if our sample size is 51, that means our degree of freedom is just 50. Oh, I see why they did this. So if our degree of freedom is 50, but it's not on the table, we need to find the closest lower one, which is going to be from this table, just 40, because we want to give as high a margin of error as we can. Okay, so that's going to be for 99%, 2.704. Okay. There we go. All right, let's see here. Okay, suppose we are given these numbers for a certain population, and these are the numbers I'm looking at here. Let's do blue. Our sample size is 81, our mean is -20, and our standard deviation is 6. Okay, so our formula for the margin of error is here, as E is equal to T of alpha over 2 times the standard deviation divided by the square root of 81. Okay, so what I did is just from the table, I found my T of alpha over 2 to be 1.664 because we are trying to find a 90% confident interval, and my degree of freedom was 80. Okay, a 90% interval, my degree of freedom was 80. And then it wants us to go ahead and finish the interval. So I take that number and I multiplied it by, oh, I guess I didn't do the math on here. I'll just do it now. That'll be good. So I multiplied that number from the table times, to find E, I had to take 1.664 and multiply it by S divided by the square root of N, and that was 6 divided by the square root of 81. Okay, and that value was not on here. Let me pause this while I find it. Whoops. It's not what I wanted to do. It's just trying to pause. Pause. Okay, so 1.1664, like we found in the table, times this gave us 1.11 in the calculator. And then I'm going down to find my lower bound by taking -20, which is my X bar, minus that number we just found. And to find the upper bound, I do -20 plus that number that I just found. If I do that, my lower bound is -21.11 and my upper bound is -18.89. So we can be 90% confident that the mean value for that sample is between -21.11 and -18.89. Okay, for that population anyway, not sample. We used the sample to figure out the population. Okay, there's your table. I also put a link to that in your slideshow. And this is the same thing, except we're doing exactly the same thing, okay? Except we're gonna have to find X bar, S, and N by putting these 20 pieces of data into your calculator. So if you don't remember, you do stat edit, you enter your data into L1, that's what I did. You go back to stat, arrow over to calc, 1var stats, no frequency list this time. I used L1, I'm gonna calculate. Okay, and that gives me exactly what I wrote down on the paper over here, okay? Now my step, that was actually step 2. My step 1 was to find my T of alpha over 2 for 95%. And if my N value is 20, then my degree of freedom is 19. Okay, so I need to go back up to my table, find my degree of freedom to be 19. Oh, that was the same. And I'm looking for 95%. So let me double check. Yep. So it's that same number I found at the very beginning. So 2.093. So 2.093. And now I also need to find my S of the square root of 20. And my S is 1.28. I'm going to change that here. 1.28 from the calculator information. So if I enter that into the calculator, 1.28 divided by the square root of 20, I get 0.286. So to find my margin of error, I'm going to get the number I found in the table, 2.093 times 0.286. And I get 093.599. Okay. So approximately my upper bound is going to be X bar 23.095 plus 0.599, and my lower bound is going to be X bar minus my margin of error for 95%. So let's see what that is. So we have plus 23.095, 23.694, and minus 0. Oh, I did something wrong there. 23, switched them up, 0.095 minus 22.496. So we do not have a huge margin of error here for 95%. We have X bar being in between, greater than or equal to 22.493 and less than or equal to 23.694. Now I want to show you how to do all of that in the calculadora. So are you ready? What we are going to do is go into your stat, right arrow over to tests. Okay, for this, we're going to go down to 8, our T interval, and it should be the same on the 83. Check and make sure that T interval is 8. Double check they're the same thing. Hit enter. It's going to ask me for either to enter in your data in, which we could do, or your stats. So I've already entered this data into L1, and oh no, I didn't enter this data into, oh yeah, I did. You just saw me do it. Geez. And I want to know what it is going to be for 95%. So I'm going to calculate. If you didn't want to do data, if you wanted to do stats, we could do that too. Just want to show you, if you arrow over to stats and hit enter, instead of entering in the data into L1, we could have done the first one because it just asked us for X bar, okay, S of X and our N of 20. So either thing you enter in, you should get the same answer, calculate. And right here, we just must have used different, because they didn't use the whole numbers. There's a little bit of a rounding error, but you can see our lower interval is 22.49, and I have 3, they have 6, and our upper interval is 23.694, which is exactly what I have. So there must be a rounding error. I know I used a lot more numbers than they did because I just used the one number that the calculator gave me, which is fine. So we've done it both ways, and I think this is the last one. You can use your calculator to find the entire interval, or you can use the equations, or my preference, use both and double check yourself.